introduce Sam from Sysdig, one of our great partners we have. He's going to give us a deep dive and some demos, I think, too, Sam?
Yep.
All right, let's get into it.
Perfect. Show of hands. Anybody seen Sysdig before, worked with Sysdig? Cool. All right, so I'll give you a little bit of an overview, just a few slides, and we'll jump right into a demo. This gentleman on the screen here, Loris DeGianni, he's the founder of Sysdig. He's also the co-creator of Wireshark. And the whole reason for Sysdig was basically, what happens when we move to the cloud? What happens when we move to containers, and it becomes a little bit more difficult to get to network packets in that instance, right? So he thought, well, what if we instrument right at the kernel of a Linux operating system? That way we can see every system call that's going through the kernel. And based on that, we get a superset of data that has all the network data that we had from before. But on top of that, we get the ability to see processes that are running inside of a container or on a host directly, even the files that are being written in a container or on the host, and so on. We used to say packets never lie. It's still true. Now we kind of say the kernel never lies. Cool. So Sysdig was built on an open core. The word Sysdig itself is the name of the company, but it's also an open source project. And the way we're instrumented as a kernel module, now we have an eBPF program as well that you can instrument that way. We love Kubernetes. We do a lot of Kubernetes work as well. You'll see in the demo. Anchor up there, we've partnered with Anchor for our scanning capability from a security point of view. And also we love Prometheus. We scrape Prometheus. And Sysdig Inspect is one of our projects that gives you the ability to dig into those system calls. It's a GUI similar to Wireshark to be able to get more in the weeds, do troubleshooting and forensics. Strong ecosystem partnership, as you can see. And the commercial offerings we're going to talk about today, Monitor and Secure. Basically, they're built on top of the platform. And what the platform looks like, basically, we have the infrastructure, as you can see. We deploy on a Linux host, so one agent per host. And doesn't matter what orchestrator you're using, Kubernetes, Docker, Swarm, OpenShift, DCOS, also the cloud providers that you can see that we partner with. And the two main technologies with Sysdig are really the container vision technology and service vision technology. Container vision is what we use to be able to see all the system calls, so the instrumentation at the kernel. And then the service vision is the ability to tie into the APIs of Docker and Kubernetes, the orchestrators in general. So put all this together, you get, say, data engine that we're collecting all this data, and on top of that platform, or on top of the data there, you can build applications. So we have the secure piece, we have the monitoring piece, and so on. Okay, cool. So the container vision technology is built on the instrumentation piece, as you can see here, as I mentioned before, the kernel instrumentation or the eBPF program. And we're instrumented in eBPF for COS, Container Optimized Operating System, that we'll talk about when we're instrumented in GKE. And the way we sit as a Docker container that listens to all the system calls that come through from any containers on your host, or just a plain old process that's running on the host itself. We'll see all that, and we can capture all this data into our agent, send the data to our backend, and away you go. You can also enforce security. So if any of these containers are misbehaving in some way, according to some policies that we have in place, you can go ahead and kill that container or quarantine that container. The second piece is service vision I talked about earlier, and that's the ability to tie into the orchestrator, understand exactly what your application looks like. That's important because just getting system calls without any context doesn't make a whole lot of sense. So this ability to do that, again, we're tying into the orchestrators, and so we can answer questions such as, application team X with that namespace. You can have containers running on multiple hosts, and you want to be able to see, okay, across multiple hosts, maybe across clouds, what does the application look like from a performance perspective, for example. All right, so for the demos, I got 3 demos today. The first piece is the build process. When you're building an application, that's the first thing you want to make sure that, through the CI/CD process or pipeline, you're doing your image scanning properly and so on. So it's the first demo we're going to talk about. The second piece, once you're up and running in production, you want to make sure that You're monitoring performance. You're looking at security from a runtime perspective. You have a view into all that. And then finally, responding when something comes up. How do you troubleshoot? How do you do forensics, auditing, and so on? Okay, so first demo. So I'm going to be using my Mac here as the development machine. And first thing, I'm just going to commit a change, right, for your application. And the application we're using is the Hipster Shop app that we talked about earlier, and Tim is going to show Istio on top of it. I'll talk about it very briefly. But the good thing about it is it's all based on microservices. It's built by Google, and it's 12 microservices. It's an e-commerce shopping application. Really nice to be able to demo it. So you commit your change, and I'm committing the change only for the front-end microservice. That gets pushed to GitHub. There's a webhook that goes to Jenkins. Jenkins does a build of the image, stores that in a dev repo in GCR. Sysdig is part of the pipeline of Jenkins, so we scan the image that's sitting in that dev repo. If it passes, great. Well, we pass the result actually to Jenkins, and based on that, if it's a pass, you continue the pipeline, you push that image to a production repo in GCR that gets deployed into our GKE cluster. Now, if it fails, you're going to get a report right in Jenkins showing you what happened. So as a developer, I really don't even need to log into Sysdig Secure at all. I can see the report right there, and I can update whatever the report is telling me to update. And what we're going to do, I'm going to add some vulnerabilities to that front-end microservice. I'm going to use an old Alpine image. I'm going to expose port 22 in that image. I'm going to add a password as an environment variable and add a private key in a file. I'm going to do all the things you should not be doing, right? And show you what Sysdig is going to be doing. Is going to show you. So let's exit from here. So before I get into demo, really quickly, I have one cluster here, 3 nodes running in GKE. The workloads, really quick, it's pretty much all of the microservices I talked about for the Hipster app. You have the Sysdig agent at the bottom here is deployed. You deploy it in multiple ways. One way, actually, you can go into the application section and deploy the Sysdig agent from the Google Marketplace. Just search Sysdig. So we are in the Google Marketplace. You can go ahead and configure that, give it a namespace, an instant name, Sysdig access key that you would have in Sysdig Secure. You put it here. Make sure if you're using COS as the operating system in GKE to tick this box to enable eBPF, and then you go ahead and deploy, and that's going to deploy Sysdig in your environment. So very simple. Of course, you can use it via. You can do this via the command line. There are other ways to install. We have an operator as well, so you can run Sysdig as an operator in your Kubernetes cluster. You can use our Helm charts, or just plain old kubectl commands will do the trick. Okay, so I've got my Jenkins. I don't have strong feelings about Jenkins in general. We find lots of folks using it, but for the sake of the demo, it shows well in this case. If you don't have Jenkins, you can always use whatever you're using, GitLab or whatnot, and just tie Sysdig Secure in with some webhooks. Okay, so I have a Docker file here for the front end. I'm just gonna go in here. You can see I'm creating a multi-stage build, and I will remove the Alpine latest. I'm going to use Alpine 3.4, so introducing some vulnerabilities in here. I'm going to expose port 22. Here's a file that it's a PIM file, has a private key in it. Put it in the image, why not? And an environment password here. We just save that, and what I'm going to do, I'm just going to do a git commit, introduce vulnerabilities or something. Git push. All right, let's go over here. All right, so we see the webhook got sent from GitHub to Jenkins, and we're going to start to see the build happening. So the first stage is just checking out the repo. I'm building the image, push the image to a dev repository in GCR. I'm scanning the image, and the image failed, right, as expected. So as a developer, I'm going to go, OK, well, what happened? Why did my image fail? Let's see. So we have a report built into Jenkins right here. You can see here's my image. and I got 15 stop actions. One warning, the final action was stop. Why did this fail? All right, I've got vulnerabilities, right? Medium vulnerability with an OS package, and you have some details. Second piece here, or second page, here's your Docker file that exposes port 22. Here's the environment variable that has the password right in it. And here's your private key file that was in there. Okay, cool. You can also take a look at the security tab and see the CVEs that we've caught. And as part of the policy, and I'll show you the policy at the end of this demo, we basically said, hey, if there's a fix available, then failed is built. So that's an option, and it's very actionable. Because as a developer, why would you use a vulnerable library, for example, if there's a fix available for you? So you can go ahead and fail that build, and you can go fix that. All right, cool. So let's go back. And let's remove all these vulnerabilities. Save, git commit. Now, I didn't show you the actual app. This is the Hipster app, right? And the current version, you can see here, it just says Hipster Shop. The new build that I just built will add a version in here. We'll say version 2.0 once it's completed. So let's go back to our, all right, so we see that Jenkins has successfully pushed this to the production repo and went ahead to deploy the app. So in just a little bit, once this thing comes back, you're going to see that this has been successfully deployed, and we can go ahead and double check here. Okay, you see the front end pod here. The age is 40 seconds, so it's just been deployed, and there we go. You see the newer version of the front end is now in place after we. So that's the first demo. We integrated Sysdig Secure as part of our CI/CD pipeline. Any questions so far? All right, so the second demo here is now that you have your application up and running, how do you, this is day 2 operations, obviously, so how do you make sure that your performance is good? So what I'm going to do, I'm going to kill one of the 12 services, microservices that I have here, and take a look at some troubleshooting steps. And before I do that, because I haven't even showed you Sysdig screen yet, so let's see. So the very first thing that you would see in Sysdig, you can change the groupings, right? I'm on Sysdig monitor now, and I want to be able to see maybe every single host that I have across all clusters and all the performance for any one of those hosts, but also all the containers that are inside any one of these hosts. You can see that. So that's a view from the infrastructure point of view. But if I want to change this to look at things from a services point of view, I can see all the clusters that I have. So this is Aaron's cluster, the store demo that we saw earlier, that's on-prem. So this is GKE on-prem cluster. The one above it is just the cluster I was playing with in AWS. And this is the GKE cloud cluster where I have the Hipster app running. So you can see here, I can keep drilling in. I can keep drilling in from the cluster level to the namespace level, down to the actual microservices or the deployments, down to a certain pod or the pod in here, and then the container, all the way down to the container, right? For this specific demo, I created a dashboard, and this dashboard is called the Kubernetes Golden Signals dashboard. And what it is, in absence of, if you're not aware of the SRE practices and the Golden Signals, in absence of any data that you have, what are the key metrics that you want to have for any application, right? So they define things like, show me the response time per service, request rate per service, the error rates, you know, how many deployments do I have for this particular application, and so on. What are the slowest endpoints? Okay, so everything is running fine now. I also have a topology map that you can see here. And the good thing about this topology map, it shows you As an ops person, I want to know what are the parts of my application, like who's talking to who. And I apologize, for some reason, these are supposed to be a little bit light here. These are blocks, and each one of those blocks is a microservice and how they're talking to each other. And the numbers on the lines between them is actually the bandwidth, or the volume of traffic between them. You can change that metric to a number of things like response time and so on. But the key thing here is you can keep drilling down on any one of those microservices to go down from the deployment down to a pod, to a container, all the way to the process that's running inside of a pod. So you can get really, really deep and granular. And you can continue to do that to figure out who's talking to who and what are they doing. So in this case, this payment service is using Node as the process in here, and figure out where it's talking to and so on. The other thing to note is the ability to find out what your services are doing in terms of talking to outside services. So from a security point of view, I want to know what my application is doing and who it's talking to outside. So I have all these IPs on the right-hand side are public IPs, and I can find out, okay, this particular currency exchange service is talking to this particular outbound service. Okay, so what I'm going to do really quickly, I'm going to go and kill one of my services. So I deleted the checkout service. That should introduce some problems once this catches up. So one thing it's going to do, the response time all of a sudden is going to start shooting up for my front end and load generator services. So we're looking at around 100 milliseconds at the moment. And you're also going to see the deployments right now. It was 12. It just went down to 11. You're going to also see the front end, the slowest front end. It's going to add up very quickly here. So give it another minute or so. Okay, looking at the last minute, last 10 seconds. But we're also overlaying events on top of the graphs. So here's where I killed a container, I believe. So this is where we just went and killed that service. And there you go. You can see now we're up to 2 seconds on the front end and the load generator. The error rate has started to go up. I'm seeing 500 errors. And really, if we go to the hipster shop and here, let's try to buy this vintage typewriter. Let's add it to our cart and let's place your order. See, it's waiting here. It's going to take a little bit of time, and then you're going to get a big 500 error. There you go. Now, typically in a production environment, you're not going to expose the log in here. As you can see, again, the response time now is really climbing, and the errors are showing, and so on. Now, you can see also that we have an alert is going to fire at some point. For the sake of time, let's see if we can wait. For the sake of time, I'm going to just show you that the alert that once it fires, it's going to kick out a capture file. And this is Sysdig inspect. So similar, looks horrible, but similar to Wireshark, it's a GUI on top of an SCAP file instead of a PCAP file instead, right? So in this case, you get this data. We have 443,000 system calls that we're analyzing over the last 30 seconds. And we're putting these in columns. So, you know, there's a general column of file, network apps, security, performance, logs, and so on, depending on what you want to do. So if you're looking at security, you're probably going to look here. Looking at performance, I'm going to look here, for example, my HTTP errors. Try opening it again. Let's see, performance, HTTP errors. And you can see right away the 500 error shows up here. Make it look a little bit nicer. So the complete log of that 500 error, you can see right here. If you go dig a little bit deeper, latest connection, it's trying to dial this IP address and port, and it's failing. And if you go back to the services in Kubernetes, you'll find that that IP and port is the checkout service that we just killed. Right? So from a troubleshooting perspective, you can go really deep and figure out exactly what happened. If I go back to my screen, here's the alert that just fired for 500 error. I can go back inside the alert and show you what it looks like. Here's the capture file that I create once the alert fires. That makes sense? Last demo. When you're responding, now what I'm going to do in this demo, I'm going to take the role of a hacker, and I'm going to go in and do a bunch of things. First of all, anybody know what the MITRE attack matrix is? Anybody seen that before? Okay. So what it is, it's a framework of what a typical hacker might go through in their attack chain. So this is too small to see, but what you do probably is initial access. How do you access that environment? Whether you're coming in from external or you're an internal employee. Doing discovery, so using an Nmap tool, for example, to scout the network, see what's on your network, to do discovery. Privilege escalation, looking for private keys or passwords through credential access, exfiltrating some sensitive data outside of your environment, and maybe defense evasion, deleting your bash history to cover your tracks so nobody knew what you were doing when you were in there. So what Sysdig did is we said, okay, this is interesting. I have two links here. The first one is the actual matrix, which you see here, but Sysdig decided to say, okay, let's take these different points and create what we call Falco rules around them. And Falco is an open source project that Sysdig created and donated to CNCF about 4 or 5 months ago or more. And what it is, it's you're familiar with Wireshark. So think of Snort. What Sysdig is to Wireshark, Falco is to Snort. And what it is, it looks at every system call, and you can put policies in place to say, hey, you can't do this. You can't do a terminal shell in a container, for example. And we'll see these. So that's what I'm going to do right now. I'm going to go in. I selected only 6. We have a bunch. As you can see, there's a lot on that matrix. So I decided to just, for the demo, select 6 of these and go in and trigger them to show you what happens. Okay. So first, let's bring back that service I just killed. Okay. So let's jump into Sysdig Secure. And now I'm in Sysdig Secure. And actually, before we do that, I'm just going to show you quickly the policies. So I created some policies in here. And this is for runtime security. So I got six of these that I mentioned in the PowerPoint. Terminal shell in a container. You should never be doing a terminal shell in a container in production, right? It defeats the purpose of containers being immutable. If you want to do that, do it in dev, but not in production. Launch privileged container. Be careful with that. Discovery, in this case, launching a suspicious network tool in a container. And we're going to run Nmap for that. Exfiltrating data outside of your environment. Deleting your bash history, and then doing a search for keys. In any one of these, I'm going to choose this one in particular because I created a capture file for this. You can see how you define the policy. You can specify scoping for the policy. So maybe I'm interested in my cluster, that's my production cluster only. So I don't care about dev at the moment. I'm really focused on a production cluster. And in the capture file, you can define, hey, I want to see 10 seconds before the event and 20 seconds after the event. So we have a ring buffer. We can go back in time and see what happened just before an incident was created. All right, so let's start creating these. Let's see if I can. All right, so the first thing I'm doing, I'm creating a privileged container. And then I'm going to exec into it. Okay, so now I'm inside the container. Now this command here, I'm actually creating a bash history file because this container doesn't have a bash history, but for the purpose of the demo, I'm simulating if you have the bash history on a host, And these, by the way, these commands or these policies can run directly on a host or inside of a container, and we'll be able to still capture them. So now I'm inside the host. I created a bash history file. I also created ran an nmap command. And just for the sake of time, I'm looking for one IP and one port. But generally speaking, a hacker will go across subnets to try to figure out what's going on. Then I'm going to grep or look for a private key file, which I already embedded into this container for the demo. So here it is. I found this same throwaway.pim file. And then I'm going to copy. This is the exfiltration here. So I'm going to copy that same private key that I found into another file, and then I'm going to run this Python app or Python script to connect to an external machine that I set up to send out that information. And I'm just going to delete the bash history. Right? If we wait just a little bit, let's see, last 10 minutes, we should start seeing these fire. Now, you don't want to wait too long. For the purpose of the demo, right, I'm showing you from a forensics perspective if I didn't have anything set up. But typically in any of these cases, you want to kill the, and I can show you right now from the very beginning, you want to kill the container or even pause the container. If you launch privileged container, maybe, okay, fine. But if you try to do a terminal shell in a container, the action I would take right away is to stop or kill that container. Right? For the purpose of the demo, I'm letting it go through so we can dig deeper. But I would definitely stop the attack right from the beginning. All right, let's see how far we've gotten. Okay. All right, so you can see here all the events that have fired. The privilege, let's see, from the privilege escalation to the terminal shell and container. And if you click on any of these, you can see the actual commands that will run. And before I click on that, it give you the scope. Where did this happen? This happened in that hipster app namespace. What's the name of the pod? Here's your name of your pod. It was not a deployment, so there's nothing here. Here's a container ID. What's the host that this happened on? What was the MAC address of that host? Give me a quick summary of what happened. Here's a quick summary of the commands that were written. Here are all the commands that I just ran in front of you inside that CLI. From the creating of the bash history to the nmap. And you can even see, what shell ID did I use? What's the process ID or the parent process ID? What working directory was I inside that container? Here's the grep command, the copy command, the Python command, all the way to shredding the bash history, right? So all the commands are here that you can see. But specifically, let's dig into the capture. Remember, I created a capture file. Whenever somebody tries to exfiltrate something out of my environment, let's go inside that capture file and take a look. We're back into Sysdig inspect. And if I go back just for a second to look at those commands again, because I know we did this copy. So this throwaway file, remember that throwaway file, we're going to search for it. And remember this connect.python file, we're going to search for it as well. First thing here, I want to find out where the notification fired. It fired 10 seconds right here into the capture, because we said capture 10 seconds for me before the event and 20 after. From a security point of view here, look at this. There's an SSH connection that occurred right around the time where the thing fired. So here's the correlation. So what's this SSH connection attempt? I don't know if you can see this, but you can see here that here's my local IP, here's my external IP. It's a public IP address on port 22. And what I did, that Python script is really running SCP. I'm just sending a secure copy outside my environment. So that's good. Well, not really good, but at least I know where this went. If we go back and take a look at the accessed files, and let's do a quick search for that here you go, throwaway.pim. Let's take a look inside of that file and see what's going on. So now I can see the content of that file. Here's the private key, the entire private key that was exfiltrated out of the environment. Let's go back and look at the connect file. You can see we find it here. There we go. And here is the actual Python. I deliberately didn't want to show it to you until I show it to you inside of Sysdig. So what it is really, it's an SCP put from that my file into an external file that lives in a hacker's machine in AWS. And here's even your username. So from a forensics perspective, we get really deep and find exactly where or what happened. Once again, from the policy, I would have defined that, just kill this container or pause that container from the very beginning, so I don't have to go through this. Does that make sense? Any questions?
If you kill the container, you don't have this data available later to take a look and see what happened.
No, not in that case. Yeah, I would kill it right away, and that's it.
So it doesn't get stored anywhere.
Because you need to, some things will. So depending on where you define that. So if I go back here and back to the policies, if you define to kill the container here, you're going to still see the privileged container escalation because that was one step before, and that all will get recorded. So it really depends on where you're going to kill it. Now, one other thing from a commands audit perspective, here are all the commands that I saw in that container, but you can always say, hey, show me every single command in my entire infrastructure and whether those commands were run inside of a container or was run on a host. So everything I showed, it could have happened on a host itself. Somebody trying to own the host and do things on the host, we can see that, so on. Cool? Yep.
Dashboard, does that integrate into some alerting mechanism? Short of having this up, how else would I be notified?
Yes. So I don't think I showed this, but yes, you can send alerts. We have notifications into VectorOps, PagerDuty. We have webhooks. You can go anywhere you want, really, depending on what you have in your environment. But yeah, absolutely.
We have a custom alerting platform. Hopefully, so there's an API on top of it.
Yes. Yes. Everything I show here from the UI has an API that you can access directly. So you're good to go. Cool. Thank you.